Hello again, back here with lesson 2 of Unit 5. This is substitution and elimination. So these are two of the more common methods for solving systems of equations. We talked about graphing as another method in the first lesson. Substitution and elimination, two more methods that really revolve more around or center more on the equations themselves. And the calculator can be helpful, as you can see here, but we'll jump right into it. So, solve the system of equations using substitution. So what substitution really means is you are going to have one or the other of your equations solved for y or solved for x. Okay, it doesn't really necessarily matter which one is solved in terms of the variable being isolated on one side of the equal sign. Either one would work, but what you're going to do then is once you have one of them solved, like we do right here, this is already a y equals negative 2, you substitute that negative 2 in for y in the other equation. So the reason it's called substitution is because we are going to rewrite 4x minus 3, but again, since we know that y is equal to negative 2, we are going to replace the y with a negative 2, which we can only do once we know what the y equals or what an x equals. So here, since y is equal to negative 2, we can put it right into the equation. So now we work from here and solve. So 3 times negative 2 is negative 6. So we've got 4x plus 6 equals 18. Okay, and what we're going to do now is solve for the x. And again, the reason we substituted is because we only want one variable. Okay, in the beginning, when there are two variables in this equation, as there were from the outset with an x and a y, very difficult to solve that. It's a much different process to solve when you have two unknowns in there. And so you have to go through a process to essentially make one of the unknowns a known value, which is what we did by substituting that negative 2 in there. So now what that did is by now not having the y in there anymore and just having the x, we are able to solve for that x. So what we know now is that x equals 3. Well, that means that the first part of our answer is 3, but we still need to solve for that y. So how do we solve for the y? Well, we now can take this equation if we needed to and put the y in there. The reality, though, is if before we go through that process, we do have to recognize that we already know the y. That was in the first equation. So our answer here is going to be 3, negative 2. Now, again, a lot of times you will have this will be a little more complicated, like it might be negative 2x plus 3, and that's what we substitute. If you have that, then you do have to take this equation, put the 3 in for x, and now go back and solve for that y. Okay, so you have 12 minus 3y equals 18. We can subtract the 12 from both sides. So that gives us negative 3y equals 6. And we can divide by the negative 3. So that gives us y equals a negative 2. So, of course, we didn't need to go through that process in this particular example, but in most we will, where once we solve for the first variable, we have to then take that and put it back into an equation. And we'll talk about what equation is easier to put it back into. And this one, of course, the top one would have been easier to put it back into since it already solved for it. But you can technically put it back into either in order to solve for the other variable. So here we go. Here's one where we have one equation solved for y, so that's a check, so that's good. So what we're going to do is we're going to take what y equals and substitute that right in for y in that equation. And you can see now once we solve for x that it's going to be a little more work to come back and solve for y. Okay, but here we go. Let's solve for x here. So what we're doing is we're taking and substituting the negative 2x plus 9 into this equation. So it would look like this. And again, the reason we're doing that is because our first equation was already solved for y. which is the first step here, is to get one of the equations. And again, it doesn't need to be y, but one of the equations needs to be solved for x or y. And in this case, it was already solved for y. So we go through this process. We have to distribute. So we've got negative 6x plus 27 minus 2x equals 11. Okay. Negative 6x and negative 2x means we've got negative 8x's plus 27 equals 11. We subtract the 27 from both sides, so hopefully this is review for you from our first unit. And then 11 minus 27 is a negative 16, because again, we're subtracting more than we have, so we go into the negatives. And we divide both sides by a negative 8, so x equals 2. So our answer is going to be 2 something. We just don't know what that something is yet. So now we got to take that 2 and put it back into either of our equations. Well, it makes sense to probably put it into the top equation because that one's already solved for y, so we don't need to, we can just substitute it in for x and not have to move around or manipulate the equation at all by adding an x to both sides or subtracting a y from both sides or anything like that. We can just now take the equation y equals negative 2x plus 9 and substitute in 2 for x. So that would be y equals negative 4 plus 9, which is y equals 5. Okay, so now that's 5. So we can take that 5 and put it right into our coordinate there. So our answer here would be 2, 5. And again, we could verify this by putting 2 in for x and making sure that it solves properly, or putting 2 and 5 in on this one, on the second equation, and making sure it equals 11, which it does. If you look at 3 times 5 is 15, minus 2 times 2 is 4, so 15 minus 4 equals 11. So that works. So we've got ways to make sure that our answer is correct before we move on. It's just a matter of putting in the effort to take our answer and actually put it back into the equations to make sure it works. All right. So here's one, again, where one of them is solved for y. Okay, so we can just go ahead and take that equation right here and substitute that in for y. So, well, let's rewrite that as 10x minus 2, and then in parentheses, 5x plus 4. Again, we're just replacing this equation for the y there, equals 4. So there's our substitution. And I'll just work relatively quickly through this. So this is minus 10x. And then 2 times 4 is 8. But it's negative 8. Sorry about that. So I'm going to just write minus 8, which or could be plus a negative 8. But you perhaps already saw this, but we've got something interesting going on here. We've got 10x minus 10x. So what happens here is 10x minus 10x is 0. So we are left with negative 8 equals 4. This can't happen. So something's up here, and we're going to figure out what it is. But we know that since this can't happen, what's actually happening here, and let's take, just to show this, let's solve this equation. So we've got 10x minus 2y equals 4. Let's solve it for y. So if we subtract 10x from both sides, gives us negative 2y equals negative 10x plus 4. Divide by a negative 2 on both sides. And when you do that, it gives us y equals 5x, that's negative 10 over negative 2 is 5. And then 4 over negative 2 is a negative 2. So we've got y equals 5x minus 2. Well, when you look at this, okay, you've got this equation here and this equation here now have the exact same slope, but different y-intercepts. Okay, so if we were to graph these, it would look something like this. One of them would look like this, and the other line would look like this. Okay, the issue here is these lines are parallel. And since they are parallel, they never intersect. And since they never intersect, there is no solution to the system. So the reason we ended up with this -8 equals 4 that didn't work is because there are truly no solutions to this problem. So your final answer would be no solutions because of the parallel lines. And because, of course, that couldn't happen. Okay, so here's another substitution example. And what we have here is one of them solve for x. And so this is obviously a little different look, solve for x instead of y, but it doesn't change anything for us. All we are going to do now is take this equation and substitute it in for x. Again, once you get one of them solved for x or y, then you're ready to just take whatever that x or y is equal to and substitute it back in for that variable. So what we have here now is 2 and then -3y minus 4 plus 6y equals -8. And a good way to check if you're making a mistake with something is if you have a y and an x in the equation that you're writing here, that's an issue. Okay, the whole reason we substitute is to have only y's or only x's. Doesn't really matter which one we have because we're going to solve for both of them eventually, but we start with only one of them there. So distributing here gives us a -6y and a -8. 2 times -4 is -8. We add the 6y, and that equals -8. So again, you can see we're heading toward a unique case again. And the unique case this time is that we end up with -6y plus 6y means that those are gone. So we end up with -8 equals -8. Well, -8 is going to equal -8 all the time, okay? So what happened here is, and I'll just show this quickly, is that original equation, if we solve that for y by adding the 4 to both sides, so that's x plus 4, and this is -3y. So we divide both sides by -3, so that ends up being y equals -1/3 x, or x over 3. X over -3 is fine too. Minus 4/3, okay, because of the 4 over -3 there makes it a minus. Okay, so that's one equation. Now the other equation, when we solve for y, 2x plus 6y equals -8, we subtract the 2x from both sides. So that gives us 6y equals -2x minus 8, and we divide by 6 on both sides. That gives us y equals -2/6, or -1/3 x, and then -8 over 6 is also -4 over 3, and you can see what happened. These are the exact same line. So for that reason, when that happens, our answer ends up being many solutions. Okay? And so what happened here again is these two, since they actually did equal each other, it was many solutions. Whereas on the last slide, it was like a 0 equals 8, which never will happen. So that's why that is no solution. So if the slopes go away, or the variable goes away, I should say, like it did here with the -6y and the 6y, what you're really looking for is if you're left with two numbers, as we were here, are those numbers equal to each other? If so, then we know it's many solutions. If those numbers are not equal to each other, then we know it's no solutions. So in general, whether it's substitution or even a little bit with elimination, it's really about finding that loneliest variable. So if you have one that's solved for y already, or you have one that doesn't have a number in front, those are probably going to be your easiest to isolate. So if you're solving for y or solving for x, you probably want to, for instance, in this one right here, if you're going to solve the second equation, solve it for x. If you're going to solve the first equation, solve it for y. Okay? But then when it comes to elimination, what you're trying to do there is actually look for variables that can offset each other. Okay, and what I mean by offset each other is, for instance, like right here, we have a plus y and a minus y. Those two would offset each other. Okay, so that's a positive. When you look at this one on the left side over here, I'll change to a different color. You have a 2x and an x, so those are both positives, but you have a positive 2y and a negative 1y. So those are going to be a little easier to offset each other if you decide, let's just double this top equation, and then we'd have a negative 2y. So if we doubled it, it would be 4x minus 2y equals 8. Well, now we have two that offset each other, okay? On this third one here, this is a little different. We've got a y and a y, we've got a 3x and an x, so everything's positive. So at some point, you're going to have to convert something to be negative, and you'll find that it's probably easiest, if as long as these are just equal to each other right now, to just offset the y's. And so you just multiply one of these by a negative 1 to just turn everything negative. So that would make it a negative y equals negative x minus 5. Okay, if everything just gets multiplied by a negative 1. Okay, so lonely and offsetting is what you're looking for. So here we go. When we look at this elimination example, what you can see is here's our key. The 4 and the negative 4 already offset. So what we are going to do, and this is where elimination comes into play, the reason we want them to offset, which I didn't reference last slide, is we're going to basically add these two equations up. And when you add the two equations up, we're just trying to line up the x's, line up the y's, and line up the regular numerical value. So 4x minus 4x, of course, is 0. Okay, so that's gone. 8y plus 2y's is 10y's. Okay, and then 20 and negative 30 is negative 10. So again, we're just adding them. So when we divide by 10 here, just like that, we have solved for y. Okay, so y is a negative 1. Now our goal is to just find whatever equation we think is going to be easier to work with and substitute negative 1 in for y. When I look at these two equations, personally, I think the first equation looks a little easier to work with because everything's positive on both sides of the equation. So what I am going to do is I'm going to take negative 1 and put it right in for y, and I'm going to solve that equation. So that's 4x plus 8, and then times negative 1 equals 20. So that gives us 4x minus 8 equals 20. I'm going to add 8 to both sides. So I've got 4x equals 28. Divide by 4, and so x equals 7. Okay, so I found my y equals negative 1 first, put that back into either equation. I picked the top one, I solved that equation for x, and now I've got my answer of 7, negative 1. And again, you can always then check your answer by putting those values back into either or both equations and making sure it works. For instance, if I wanted to put it back into the second equation, it would be negative 4 times 7, since x was 7, plus 2 times negative 1. Well, negative 4 times 7 is negative 28, and 2 times negative 1 is negative 2, so negative 28 plus negative 2 equals negative 30. Excellent, it worked. All right. Okay, now looking at this one here, this example, we do have offsetting variables once again, and our offsetting variables, as you can see, would be the negative 9y and the positive 9y, which means we can just combine these again by adding the two equations. So the x's that line up here, negative 2x plus 4x, leaves us with 2x. The y's are gone, and negative 25 plus 23 is negative 2. So we divide both sides by 2, and x equals negative 1. So once we get x equals negative 1, we can pick what equation we want to put it back into to solve for the y. I think I'm going to put it into the bottom equation this time. And so the bottom equation with a negative 1 in for x here is now 4 times negative 1 plus 9y equals 23. That would be negative 4 plus 9y equals 23. You add the 4 to both sides. So 9y equals 27. divide by 9 on both sides, so y equals 3. So our answer here would be -1, 3. And that would be, again, if we could put those, or if we wanted to put that back into either or both equations, we would find that, for instance, -2 times -1 is 2. 9 times 3 is 27, so 2 minus 27 equals -25. So the top equation works. Bottom equation, 4 times a -1 is -4. 9 times 3 is 27. So that would give us -4 plus 27, which equals 23. So that's a check. Both equations check, and we know that our answer of -1, 3 is correct. Now here is a situation where they do not align perfectly, okay? We've got a -6x and a -6x. We've got a 6 and a 3. So we've got to do something here to get them to offset. Well, the easier play here to get them to offset, you would probably argue, is to just make one of the 6's in front of the x positive, okay? Otherwise, if you do the y, you got to either double one or cut it in half and change its sign. You either have to double the 3 or cut the 6 in half in front of the y and make one of them negative. So instead of doing that, let's just take this whole second equation and multiply it by -1. Now what that does is our red equation stays the same. So our red equation is still this, okay? But our green equation now, I'll try to make this a little darker. Let's see. No, let's just leave that. So our green equation is now -1 times -6 is 6x. -1 times a positive 3y makes it a -3y. And -1 times a -12 is a positive 12. So I haven't changed the actual result of that equation at all. I've just changed the sign of everything. So this will do nothing to change our final answer. It just allows us now to combine these equations, and now the x's are gone. So that leaves us here with 3y equals 18. We divide by 3, so y equals 6. Okay? Now, from here, you have a choice. You could put this y equals 6 back into either one of your original equations or your new green equation. It does not really matter. So let's just put it back into the top one that we didn't mess with at all. And again, we're now taking the 6 and putting it in for the y there. So we've got -6x plus 6 times 6 equals 6. A lot of 6's there. So -6x plus 36 equals 6. We're going to subtract the 36 from both sides. So we've got -6x equals -30. You can, again, if you want to use your calculator there, but -36 plus 6 is -30. You divide both sides by a -6, and you get x equals 5. So our answer here, and even though we found the x second, just remember that that goes first. So our answer is 5, 6. Okay, and again, you could put that in for either equation or any of your 3 equations, either of these two or the new one, and make sure that it works. So let's just put it back in the new one. 6 times 5 is 30, since x is 5. So 6 times 5 is 30. 3 times 6 is 18, so that's 30 minus 18, which is 12. So that's a match. Again, we could put it into either of the top equations as well. It's going to work. So our answer there of 5, 6 is a correct answer. Check. Let's see here. We can do these last two. So on this here, if you look at the y's, if you just triple that bottom y, then those two will offset. So what we're going to do here is just put a 3 out in front of the bottom equation, and we are going to rewrite this as -4x minus 15y equals -17. And now we're going to triple that second equation, and so that ends up being -3x. Again, we aren't changing the sign, we're just tripling. So instead of -1x, it's now -3x. Instead of 5y, it's now 15y. And instead of negative 13, it's negative 39. So again, you have to triple the whole equation there. So just a reminder with that. And now we can have these offset and solve from there. So we've got negative 4x and negative 3x is a negative 7x. The y's are gone. And we've got negative 17 and negative 39, which is a negative 56. So we divide by the negative 7, and we get x equals 8. So now we take that x equals 8, put it into either equation to solve for the y. So I'm just going to take this red one up here. So I've got negative 4, again, x equaled 8, so I'm going to put 8 in there, minus 15y equals negative 17. So that's a negative 32 minus 15y equals negative 17. I'm going to add 32 to both sides. And look how nicely this works out. We end up with negative 15y equals 15, because 32 minus 17 is 15. We divide by negative 15, so y ends up equaling, again, this was a positive 15 over a negative 15, so that's a negative 1. So our final answer there is 8, negative 1. And we could put that back in to either equation, either of these two, or the new green one, and we would find that 8, negative 1 is a correct answer. Let's see, positive 8, negative 8 plus 5 times negative 1 gives us negative 8 minus 5, which is a negative 13. So that checks. All right, let's make last one really quickly here. This one we need to really work with, because we can't just double something or cut something in half or anything like that. We have to get a way to make these match, and I think what you'll find is we have two options. We could either get these, we could double the top equation and multiply the bottom equation by 5, and that would make this a 10 and a negative 10 here. Or we could multiply the top equation by 3 and the bottom equation by 4, which would make this a 12 and a negative 12. Either way works, it doesn't really matter at all. And so we just pick whatever one we prefer of those two. And so I'll just take this top one and double it, and this second one and multiply it by 5. And now I would rewrite this. Again, it's all about making these offset, but the x's or the y's aren't going to offset here by just manipulating 1 unless we multiply it by a fraction, which just makes our work that much more difficult. So my red equation now is, now 10x plus 8y equals 12. Again, I just doubled it all. My green equation is now 5 times negative 2 is negative 10x. 5 times negative 3 is minus 15y. And 5 times negative 1 is a negative 5. Sorry, that got to be very light there. But now I can take this, oh, that's because I was using the highlighter. Okay, so that's negative 10x minus 15y equals negative 5, which again is just every value in this equation multiplied by 5. Okay, now my x is offset, which was the goal when we multiplied them by 2 and 5. My y's get to be a negative 7y, and on the right side, 12 and a negative 5 is 7. I divide both sides by negative 7, so I get y equals negative 1, so y is good. Now I just pick whatever equation I want to put that y equals negative 1 in. I'm just going to put it right back into my top one. So that gives me 5x plus 4 times negative 1. Again, that's because the y was negative 1 equals 6. So that's 5x minus 4 equals 6 plus 4 on both sides. And again, that's now minus 4 because 4 times negative 1 is a negative 4. So I just changed it to a minus rather than being plus a negative. 5x equals 10. Divide by 5 on both sides, so x equals 2. So my final answer after all that work is 2, negative 1. And again, if I put 5 times 2 here, plus 4 times negative 1, 5 times 2 is 10. 4 times -1 is a -4, so it's 10 minus 4, which equaled 6, which is what it was supposed to do from the beginning. So 2, -1 is our correct answer. Thank you for listening all the way through that. If you have any questions, as always, please ask. Take care.